resolving vectors means splitting a vector into its components. So consider we have a vector A which is lying along a particular direction. And now let's say if I show x-axis and y-axis with these dotted lines. In the question, let's say they have given you the vector A and the angle theta. So the angle theta is between the vector A and the x-axis. Now, how do we split this vector into two components? So the first step is consider this endpoint of A. We will draw a dotted line which is perpendicular to the x-axis. So this green dotted line is perpendicular to the x-axis. Now, what do we mean by x component of A? So we have to break the A into two components. One component will lie along the x-axis and the other component will lie along the y-axis. And what is meant by component? Component basically means if you have a vector, you need to figure out the projection of that vector along a particular axis. So along the x-axis, if I draw a vector starting from the origin all the way till this point, this will be the x component. And then this green dotted line which we have drawn, this is the y component of the vector A. We can also drag this AY vector on the y-axis. So AY vector can also be represented like this along the y-axis. Now, how do we figure out the magnitudes of AX and AY? Because that is what we are supposed to do, resolving vectors. So we will be using the basic trigonometry. If I use sine theta in this particular right angle triangle, sine theta, remember, is opposite upon hypotenuse. So the side opposite to theta is AY and the hypotenuse is A. So sine theta will be represented as AY divided by A. And let's make A as the subject from this equation. We will get AY as A sine theta. Similarly, to get AX, we will be using cos theta. Cos theta will be base upon hypotenuse. So the base is AX. So that's why cos theta is AX upon A. And if we make AX as the subject, we will get AX as A cos theta. This is what we meant by resolving a vector into its components. This is called resolving vectors. So in the exam scenario, all we need to remember is if the vector A is given and we are supposed to find its x and y components. So how do we do that? The x component will be A cos theta and the y component will be A sin theta. This is what is meant by resolving of vectors. Now, let's read this. Resolving vectors is opposite of vector addition. What do we mean by this? So consider we have two vectors AX and AY and we are supposed to find the net force between these two vectors. So how do we do that? We do that using the parallelogram law of vector addition. Step 1, remember, was to create a parallelogram using these two vectors. Step 2 was to draw the diagonal. Now this diagonal will give us the resultant force of these two vectors AX and AY. So in the parallelogram law, we are finding the resultant. In resolving vectors, we are breaking the vector into its two components. That's why I mentioned that resolving vectors is opposite of vector addition. Now, while resolving vectors, it is very important for us to notice the angle theta. So in this example, we saw the angle theta was between the vector itself and the x-axis. That's why we did AX was A cos theta. But consider another situation. We have the same vector, but the angle theta is given with respect to the y-axis. And now in this case, even if you use the same trigonometric analysis, we will figure out that the x component will have the sine parameter and the y component will have the cos theta parameter. And in the exam situations, this is a very, very common mistake which students make. We need to be careful about the angle theta. About which axis is the angle given. Now, in order that you do not forget this, I have placed a shortcut how to find the components of a vector. So what is the shortcut? Let's see. If the angle theta is with respect to the x-axis. So for example, in this diagram, theta was between the vector and the x-axis. In this case, the x component will have the cos parameter as you can see. So AX will be A cos theta. And then the y component will have the sine parameter as you can see here. So AY will be A sine theta. On the other hand, if the angle given is with respect to the y-axis. So for example, in this diagram 2, the angle was between the original vector and the y-axis. In this case, the y component will have the cos parameter. So AY will be A cos theta and the x component will have the sine parameter. As you can see here, AX is A sine theta. That is why, while solving questions, please be careful about the angle theta. Is it with respect to the x-axis or the y-axis? Depending on that, our components will change. Now, coming back to the parallelogram law, where we were supposed to find the resultant force if the angle between the two forces is neither 0 nor 180 nor 90. So, we were considering a specific situation when the angle theta is equal to 30 degrees. So, I had said we can find the net force using the parallelogram law, but we also need resolving vectors. So over here, you can see the 6 Newton forces along the x-axis. So we can keep that as it is. But the 4 Newton force is neither along the x-axis nor along the y-axis. So it is important for us to break this 4 into the two components, the x component and the y component. All right, let's go. So 4 is at an angle of 30 degrees with the x-axis. Remember, now the x component will have the cos parameter. So the x component of 4 will be 4 cos 30 and the y component of 4 will have the sine parameter. So it will be 4 sine 30. Now observe carefully, this 4 cos 30 and the 6 Newton force, they are acting in the same direction. So the angle is 0. If you recall, whenever the angle between the vectors is 0, we add the two vectors. So the total force acting on this object along the x-axis will be 6 plus 4 cos 30. We have done just basic addition. But on the y-axis, we only have one force. So 4 sine 30 is the force acting along the y-axis. And now we can very easily find out the resultant. Remember in the earlier case, when the angle was 90 degrees, remember whenever the angle theta is 90 degrees, we can very easily use the Pythagoras theorem. We need to use the parallelogram law. Step 1, let's create a parallelogram using the two sides. Step number 2, is to draw the diagonal. This diagonal gives us the net force. Now, since the two components are perpendicular, we will be using the Pythagoras theorem. So the net force magnitude will be given by square root of 4 sine 30 whole squared plus the entire 6 plus 4 cos 30 squared. If we solve this, we will get approximately 9.67 newtons. And to find the angle alpha, we can use basic trigonometry, either sine, cos, or tan. So let us use tan alpha. Tan alpha will be opposite upon base. So the side which is opposite to alpha is this green dotted line, and the length of this is nothing but 4 sine 30. So the opposite is 4 sine 30 and the base is 6 plus 4 cos 30. So tan alpha will be 4 sine 30 divided by 6 plus 4 cos 30. And if we find the inverse of this, we will get the angle alpha. And now let us summarize what we have learned so far in the law of vector addition. Case number 1, when the angle between the force was 0 degrees, the resultant was 10 newtons. When the angle was 180 degrees, which means forces were opposite, the net force was 2 newtons, that was found using subtraction. Case 3, when the angle between the two vectors was 90 degrees, we use the Pythagoras theorem to find the net force as 7.21 newtons. And in the case 4, which we just discussed, when the angle was 30 degrees, then the net force was 9.67 newtons. Now, if you analyze very carefully, the magnitude of the resultant forces keeps on changing depending on the angle. And that is the condition which every vector should satisfy. Resultant of vectors depends on the angle between the vectors. And now let us solve a question based on resolving of vectors. In this question, we have been given a force of 250 newtons acting at an angle of 30 degrees to the positive x-axis. So the diagram is this. The question is, we need to resolve this 250 Newton force into its components. So we need the x component and the y component. The only thing which we need to be careful of is the angle theta. The angle theta is given with respect to the x-axis. That means the x component will have the cos parameter. So the x component of force will be f cos theta and the y component will be f sine theta. So fx, the x component of force is f cos theta. The magnitude of force is 250 and the angle is 30 degrees. So the x component will be 250 cos 30, which is 216.5 newtons. And the y component will be f sine theta. So 250 sine 30 and we get 125 newtons as the answer. And that is how we resolve a particular vector into its two components. An object of weight 100 newtons is kept on an inclined plane. The angle of inclination is given as 60 degrees. Now we need to resolve the force into components parallel and perpendicular to the inclined plane. So far, we had been resolving a vector into the x component and the y component. But we can resolve a vector in any two directions as long as the two directions are perpendicular. So in the previous case, we saw the x-axis and the y-axis are of course perpendicular. In this question, they want us to resolve the weight force into components which are parallel to the inclined plane and perpendicular to the plane. How do we do that? Let us discuss. So this is an object whose weight is 100 newtons, and weight of an object always acts downwards. So in this diagram, if I draw an arrow of 100 newtons acting downwards, this is the weight of this object. Now we have to resolve this 100 newtons into two components. One component should go parallel to the incline and the other component should go perpendicular to the incline. How do we do that? Let's draw a dotted line which is going perpendicular to this inclined plane. So this angle is 90 degrees. Now remember, in order to break a vector into components, we need the angle theta. So what will be this angle? To figure this out, let us consider this entire right angled triangle. If this angle is theta, this angle over here will be 90 degrees. So this small angle will be 90 minus theta. But since this entire angle, the dotted line with the inclined plane, this entire angle is 90 degrees, which means this small little angle will be theta. And now we can resolve the 100 vector into the components. But remember the shortcut, the angle is important with which axis it is given. So in this case, the angle theta is with respect to the dotted line. So the component of 100 Newton, which is going along this dotted line, will have the cos parameter. So this component will be 100 cos theta, and the component of 100 Newton, which is going parallel to the incline, that will have the sine parameter. So 100 sine theta. And now we can very easily calculate. So the component of weight, which is going parallel to the incline, it was 100 sine theta, and the angle theta is given as 60 degrees. So 100 sine 60 gives us 86.6 newtons. And the component which is perpendicular to the incline, that was 100 cos theta. So the value is 100 cos 60, which gives us 15 newtons. And that is how we figure out the two components in this case.